The one thing that makes confounding really different from other sources of bias is the fact that we can actually do something about this. We can do something about the issue of confounding either in the design phase, or we can even address it in the analysis phase after we've collected our data. So in the next few slides, we're going to talk about some of the strategies that we can use in research to actually control for confounding in our research studies. So the initial phase in which we can address confounding is in the design phase. So when you're actually designing a research study, you can use what we call restriction. You can also use randomization, and then you can also use what we call matching. Or if you don't address for confounding in one of these design phases, you can actually control for confounding even after you have collected your data through the use of stratification as well as multivariate modeling. Now, if you decide to address a potential confounder, you have to collect information on that variable. So if you, for example, think that gender could be a potential confounder and you get to the analysis phase and you want to control for gender, but you never collected information on gender, you can't control for gender in your analysis. So it's really important to think about, before you start collecting data, what potential variables you might run into in terms of confounding. The first strategy that we can use in the design phase is what we call selection or restriction. We typically use selection or restriction when we're talking about only including one strata in your study. So let's say, for example, I think that gender might confound the relationship between an independent and a dependent variable. Well, if I only include one option for gender in my data, so for example, let's say I include only men and I don't include people who identify as women, I am excluding that other variable, and therefore gender can't be a confounding variable in my study. I've only included people who identify as one particular gender. There are some advantages and disadvantages to each approach. In terms of advantages, I would say that this one is pretty easy to do. It's pretty easy just to exclude a specific variable option in your study, and it can be pretty cheap to do. So it's pretty easy, simple, cheap. Disadvantages is that you only have information on that particular strata that you included. So let's say that I want to look at gender effects in my study down the road. If I only included information on people who identify as male, I can't actually look at the effect of gender down the road. It decreases generalizability given that you're limiting the people who can be included in your study. And again, you really can't evaluate for any kind of effects, which can pose a challenge if that's something you become interested in later on. This is also something to think about for your lab project for this course. If you are selecting variables as potential confounders, historically, this class has had a student population that has been, I would say, primarily people who identify as female. And so students have wanted to include gender as a control variable in their analysis for their lab projects. However, a lot of times our classes are essentially at the point of restriction where we don't have any students who identify as male and we only have students who identify as female. So you might want to consider that if you're thinking about a variable like gender in your lab project. Another way that we can address confounding is randomization. Remember that a confounder has to be unevenly distributed across your comparison groups. So the idea in something like a randomized clinical trial is that you randomize people to the exposure. So you don't really get those unequal distributions of some confounding variable across your comparison groups. You're distributing the population experiences for whatever those covariates might be. They get evenly distributed across your comparison groups. Now, simple randomization, it can be easy to do, especially when you have really large sample sizes. So it can be really easy in terms of advantages. However, at the same time, the issue of randomization, it can be really challenging if you have a small sample size. So if you have a super small sample size, it might be really difficult to randomly assign people and distribute those people according to covariates. Matching is another strategy we use to address confounding. We can use this in both cohort studies as well as in case control studies. You'll often hear about matched case control studies, and those studies are using this matching to address the issue of confounding in those studies. So for matching, what you do is you select study subjects so that the potential confounders are distributed in an identical manner across the comparison groups. It usually requires a smaller total sample size than an unmatched design, which is nice. Some pros, it's good for complex multifaceted variables. When you're doing a case control study, when there's many possible controls, but a smaller number of cases, this can be really helpful. Some cons are that it can be time consuming and expensive to match people, and you can't evaluate the effect of factors that you actually matched for. So once you do that matching, you can't evaluate the effect of that variable in which you matched on, and it can limit your sample size. One thing I want to point out is that the difference between randomization and matching, they come down to the type of studies that we have. So in observational studies, we can't use randomization. We have to use matching. We can't randomly assign people to distribute people equally across whatever covariates in an observational study, whereas in intervention studies, we can actually randomly assign people. So it's not always feasible to use randomization, especially if you have something like an observational study design. In the analysis phase, you can use what we call stratification. This is the approach that we used in our example in terms of gender and malaria. We looked at a stratified analysis where we basically separated people into those groups according to that potential confounder of working outside. And then we looked at those strata-specific measures and calculated an adjusted measure that accounted for that confounding variable. So pros of this, it can be really easy to do. You all did this in terms of those calculations, and you can evaluate for interactions, which we'll talk about in a later module, but essentially you're looking to see, does the relationship between your exposure and outcome differ according to levels of another variable? And it can be really easy to understand and provide estimates that statistically removes the impact of that confounder. So we can get an adjusted measure that basically the effect of that confounder has been removed. However, you'll kind of realize that you really can only adjust for a limited number of confounders. You're drawing out 2x2 tables essentially, and this becomes kind of an impossible approach if you've got a lot of confounders to adjust for. And then lastly, we can use multivariate analysis, which is probably one of the more common ways that we control for confounding in the analysis phase of studies. Basically, it allows us to estimate the effect of an exposure on an outcome after controlling for that potential confounder in our model. So what we do is we use a regression model. Maybe it's a linear regression, a logistic regression, depending on the data that you're using. You can basically use your statistical software and you can just plug in the covariates that you think might be potential confounders, and you will get adjusted measures of association for your independent and your dependent variable that account for those confounding variables. Some pros are that you can easily adjust for a bunch of confounders. You can just put a bunch of confounders into that statistical model and adjust for those and get an adjusted measure of association for the relationship between your independent and dependent variable. However, there are some statistical issues that arise when you put in basically too many confounders, and you do need statistical software, which can be difficult to learn how to use.